Hello guys, how are you? कैसा है बच्चे लोग? This is your KP sir on YouTube again. So myself Krishna Prakash. Students love to call me KP sir or EE sir. I have 16 years of teaching experience, trained more than 150 batches, and worked in all top coaching centers in India. Now in an academy online platform, I'm going to teach environmental engineering, hydrology, irrigation, construction materials, and open channel flow. So if you want to watch my free classes on an academy, you just search NVLK Prakash. You will get my free classes, watch the lectures, and if you want to join plus course, paid full-length course of GATE and ESC, use the code KPCivil. You will get maximum discount and all the benefits provided for you. Use the code, don't forget what is the code? KPCivil. Use the code KPCivil, then take plus subscription. You will enjoy all the benefits. You will enjoy the full length GATE and ESC subjects. So before going to start the session, just a small announcement. In Unacademy, we are providing various free online tests. In that, this is an online competition. Most expected questions for GATE 2021. Very important. Most expected questions for GATE 2021. Free test series for any one of the student who is appearing for GATE aspirant. And along with providing free test series, we are giving you surprise gifts. Win the prizes worth 6 lakhs. You can win the prizes worth 6 lakhs. So 3 series of tests. 14th November test 1 already completed. 21st November test 2 on strength of material, structural analysis, RCC, steel and open channel flow. 28th November test 3 construction management, building material, fluid mechanics and transportation engineering. So what are the benefits you are getting? First of all, you get good subject knowledge. You are going to expose to subject oriented basic questions, very important questions, most repeated questions. So you are gaining knowledge. Anyway, while writing any online test series, you are gaining knowledge. Very importantly, it is a free test series. You are not paying anything for this test series. It is a free test series. And you will get rewards. For those who got first 1 to 5 ranks, you will be rewarded with 2,000 rupees. 6 to 10 ranks 1500, 11 to 25 ranks 1000. So like that, for each branch 3 topic wise test series conducted in 3 parts we have given here. Part test 1, test 2, test 3. You are going to getting benefited learning subject knowledge. Along with that, you are getting prizes rewarded for your benefit. Okay, enroll now for the test series as early as possible. And also ISRO Revise India syllabus. ISRO Revise India series as per the recent syllabus of ISRO. Free previous year question sessions and all India ISRO mock test for all branches, mechanical, electrical, civil, EC, CS and IT, for all branches. All India series ISRO mock test from 7th to 21st November. 7th to 21st November, free PYQ classes going on. Free PYQ classes going on in an academy. Then test is conducted on 22nd November. Again, win exciting prizes worth 3 lakhs. Enroll now itself. Enroll now itself. So, from an academy end, we are ready to support each and every student. Remember, not only for paid subscribed student, for each and every student who are unable to afford the prices, we are providing free classes, we are providing free online test series, along with exciting rewarding prizes also. Everything we provide. The only thing from your end, you spend your time, write the exam, get rewarded with the exams. Okay, let's crack it. And one more announcement. From 20th November, we are going to start Spark ESC 2021 prelims batch, 7 months batch, in which myself, Rajendra Prasad sir and Praveen Kulkarni sir will teach all civil engineering subjects, core civil engineering subjects. We will take care. So take your plus subscription as early as possible using the code KP Civil. What is today's session? Today's session is related to 2017 GATE previous year questions PYQ. 2017 GATE PYQs for civil engineering, engineering hydrology, from the subject engineering hydrology. We will discuss both set 1 and set 2 questions. In detail, we will talk about solution, how we are getting solution. I am going to analyze each and every stepwise manner. I will explain you. Let's enjoy the topic.
Hey, I will challenge you in PUBG. Will you come online to play?
No, I have online GATE class. I don't want to miss it.
Who is teaching?
Top faculty of civil engineering in India, KP sir, on an academy. I am a big fan of his teachings.
Oh, yes, I have also heard about KP sir. I am willing to join the class.
It's nice. Take subscription in an academy using KP Civil code. You will be benefited more.
Okay, let's crack it.
Now, first question. Now, coming to the today's session. 2016, 17 and 18 irrigation engineering previous year questions. Why all 3 years combined I am giving? Previously we did each 1 year. 2019 one video, 2020 one video we have done. But here we are combining 2016, 17, 18. All 3 years 6 sets. Each year 2 sets, 6 sets. In civil engineering paper, irrigation engineering, they gave only 5 questions. You understand the point? All 3 years, 2016 to 2018, all 3 years combinedly from irrigation engineering, they gave only 3 years, they gave only 5 questions from it. So one small video, that is enough for us. So not individual years we are doing combinedly. 2016 to 18 irrigation engineering, civil engineering, previous year questions of GATE solutions we are doing. Coming for the first question, the intensity of irrigation for the Kharif season is 50%. I. Intensity of irrigation for Kharif season is 50%. I am writing percentage in fraction 0.5. Cultivable command area of 50,000 hectare. Area CCA, cultivable command area 50,000 hectare. But already intensity for Kharif season is 50%. Means what is area for Kharif in this case? Cultivable area 50,000 hectare. Out of that 50% only. 50% only for Kharif season. So area available for Kharif season 50% of cultivable command area. So 0.5 into CCA 50,000, 0.5 into CCA 50,000, which is taken as 25,000 hectares. This is area available for Kharif season. Duty for the Kharif season is 1000 hectare per cubic. Duty for Kharif season will take 1000 hectare per cubic. Assuming transmission loss of 90%, required discharge at the head of the canal, transmission loss of 10%, required discharge at the head of the canal, means canal is started the journey. Consider this is head of the canal. This is head of the canal. water is traveling through the canal, water is flowing through the canal and delivered at a field, delivered at field. Water started, consider water started at the head is 100%. During the journey, losses, because conveyance losses or transmission losses are there. Conveyance losses or transmission losses are there. Because of losses, it was delivering only 90%. The losses may include evaporation loss, seepage loss, runoff loss, conveyance losses, transmission losses, given, already given in the data, 10%. So it is delivering 90% at the field, delivering 90% at the field. Now here you need the discharge. Here you need the discharge. Discharge at field we can estimate using the formula. Do you know? Field discharge. Discharge at field is equal to area by duty at field. You can calculate. The 90% is this value, 100% is how much? We'll calculate. We'll do the solution. Discharge at field. Discharge at field is equal to area divided by duty at field. Discharge at field is equal to area divided by duty at field. Area we will take it now, area. 25,000 we derived already, 25,000 hectare area. Duty given 1000. So area is 25,000 hectare. Duty at the field is 1000 hectare per cubic. So this is hectare, discharge hectare per cubic. So we'll have discharge at field 25 cubic. Discharge at field 25 cubic. Q field, discharge at field is equal to 25 cubic. Now this Q field is 90%. This is 90% only, which is 25 cubics. Q field is 90%, which is 25 cubics. Q head. How much Q head? Q head is 100%. What is the value? We'll solve it now. 90% value is 25 cubic. What is value of 100%? 95% value is 25 cubic. What is value of 100%? 25 into 100 by 90. This is only 90% is 25 cubics, which is called discharge at field. 100% is how much, which is called discharge at head. 25 into 100 by 90 will get the answer. Calculate it. 27.78 cubic. 27.78 cubic. So up to 2 decimal place we need the answer. We'll write down here 27.78 up to 2 decimal place in cubic. Clear? One by one, step by step. First 50% of cultivable command area. Then area for kharif obtained. Then analysis. Water started at the head 100 liters, received at the field with loss of 10 liter, 90 liter. So discharge at the field is equal to area by duty. Then discharge at head is equal to 25 into 100% by 90%, 27.78 cubic. Next question. This is 2017 2 marks question. Previous one is 2018 1 mark. This is 2017 2 marks. Cultivable command area of canal is 10,000 hectare. CCA. Cultivable command area is 10,000 hectare. The area grows only two crops. The area grows only two crops. Rice in Kharif season, wheat in Rabi season. Both different. Rice in Kharif season, wheat in Rabi season. Two different crops. Write down. Rice in Kharif season, rice in Kharif season, wheat in Rabi season. Two crops in two different seasons they are cultivating. Design discharge is based on requirement of rice. Means highest. It may be highest. So whatever highest water requirement, maximum water requirement, that maximum discharge only considered as design discharge. Maybe rice needs maximum discharge, so it was taken. Which has an irrigated area of 2,500 hectares. Base period, area of 2,500 hectares. For what? For rice. For rice, area is 2,500 hectares. Base period of 150 days. Delta of 130 centimeter. Base period of 150 days, delta of 130 centimeter. We'll write down now. Area, base period, delta. Area of 2,500 hectares. Base period of 150 days. 150 days. Delta of 130 centimeter. Delta of 130 centimeter. Maximum permissible irrigated area in hectare for wheat. We need area for wheat. Base period of 120 days and a delta of 50 centimeter. For wheat, area required, base period of 120 days and a delta of 50 centimeter. For what discharge? For same discharge. So, for whatever the discharge for rice, the same discharge for wheat also. Discharge is said to be constant. Whatever discharge you are giving for the rice, same discharge you are continuing for wheat also. So that discharge, what is formula for discharge? Previous question we solved now. Discharge field, area by duty. Same we can take here also. Discharge is equal to area by duty. Duty provided in the data? Duty given in the data? No. Duty not given in the data. So I am taking duty is equal to 8.64. Clear? Duty not given in the data. I am taking duty is equal to 8.64b by delta. 8.64b by delta. So substituting in place of duty. So what you can take? A by 8.64b by delta. Discharge is equal to A by 8.64b by delta. So we'll conclude final formula for discharge. We'll take it now. Area into delta by 8.64b. Wherever you are solving any question, remember this point carefully. Remember this formula. Any formula, any question related to irrigation discharge, very important. Q is equal to A into delta by 8.64b. A into delta by 8.64b. But in this question, what is given? Tell me. discharge is constant, not varying. Discharge is constant. Means discharge for rice is equal to discharge for wheat. No change. So we'll equalize the discharges. We will equalize discharges A1 into delta 1 by B1. Because 8.64 will be cancelled if you equalize. 8.64 is cancelled. A2 into delta 2 by B2. We'll get now. A1 into delta 1 by B1 is equal to A2 into delta 2 by B2. If you substitute, you will get the answer. Nothing is there. A1 2500 into delta 1 130 centimeter. B base period B1 150 days is equal to A2 required delta 2 50 centimeter, B2 120 days. So required is A2 only. No? Required is A2 only. Will consider this is required. A2 required. We are taking it. So solve for A2 now. Solve for A2 now. You got the answer. If you solve for A2, you will get the answer. Easily you will get the answer. Solve for A2. So we are taking this relationship. We are using this relationship. We are getting the answer. A2. How much? 5,200 hectare. Area for wheat. 5,200 hectare. So again, this is also fill in the blank. Numerical answer type. 5,200 hectares. Means you can understand the formula for discharge. Easily you can solve it. Easily you can solve it. Even that is equal to discharge is equal to area into depth by time. Same. Discharge is equal to area into depth by time. Delta is depth. B is base period, nothing but time. So discharge constant A1 D1 by B1. Easily completed. Now, profile of a weir on a permeable foundation is shown in figure 1. This is figure 1. This is figure 1. Weir on permeable foundation given. Elementary profile of upstream pile only case. Means if only upstream pile is provided. If only upstream pile is provided, elementary profile according to Kossala's theory is shown in figure 2. According to Kossala's theory is shown. Elementary profile according to Kossala's theory. Figure 2. Figure 2. Very important. What is given in figure 2? Upstream pile only case. Means there is no downstream pile. There is no downstream pile. Only upstream pile only case provided according to Kossala's theory in figure 2. The uplift pressure head at key points Q, R and S are 3.14, 2.7 and 0. So here uplift pressure PU at S is 0. Uplift pressure at PU at S is 0. Yes, 0 na S is 0. Okay. Q and R. Q is 3.14. PU is equal to 3.14. PR. Uplift pressure at R is 2.75. 75 respectively. Then what is uplift pressure head at point P? Uplift pressure head at point P downstream of the weir, junction of floor and pile. As shown in figure 1, very important, P location is as shown in the figure 1. That is very important. Upstream uplift pressure at P downstream of the weir. Where is P located? P is located here. Downstream point. This is downstream point. P is located here. Downstream point. So this uplift pressure of P at this point is related to are according to upstream pile. You understand? Point P, which is at a downstream uplift pressure, related to point R, which is located at coastless upstream pile. Coastless upstream pile. So this is H, total head. Total head, which is equal to 4 meter. Total head, which is equal to 4 meter. This total head, which is equal to 4 meter, that H is equal to, it must be resisted. That uplift head, total head, that is uplift total head, 4 meter. This must be resisted by P and R. Upstream pile and downstream pile. Upstream pile is R. This is upstream pile and its resistance is this much, R. This is downstream pile and its resistance is P. So, total head H is equal to HP plus HR. What is total head? 4 is equal to HP you need to derive. HR given in the data na HR. Q is 3.14, R is 2.75. So we'll take it now. 2.75. Any complication in the question? Any complication in the question? Now HP is equal to 4 minus 2.75. So much data provided. Unnecessary only. But only the thing you need the concept here. Only the thing you need the concept here. Because this is downstream pile P, which is internal. And I draw here. And I draw here. P internal. So P and R needed. So we are taking like that. That is very, very important. HP is equal to 4 minus 2.7, 1.25 meters. So much data. Unnecessarily they provided so much data. 10 meter, 5 meter, 25 meter. Do you going to solve for creep length here? If you are going to solve for creep length, the total 10 meter, 5 meter, 25 meter, pile depth 5 meters, all this is total unnecessarily provided. Simply total head is equal to HP plus HR, that is taken here. HP required 1.25 meter.
Hey, I will challenge you in PUBG. Will you come online to play?
No, I have online gate class. I don't want to miss it.
Who is teaching?
Top faculty of civil engineering in India, KP sir on an academy. I am a big fan of his teachings.
Oh yes, I have also heard about KP sir. I am willing to join the class.
It's nice. Take subscription in an academy using KP Civil code. You will be benefited more. Okay, let's crack it.
A concrete gravity dam section is shown in the figure. Oh, concrete gravity dam section. Very, very important question. Maybe first time in GATE this model of concrete gravity dam provided. Assuming unit weight of water 10 kilonewton per meter cube. Unit weight of water 10 kilonewton per meter cube. Unit weight of concrete 24 kilonewton per meter cube. Means gamma W is 10 kilonewton per meter cube. Gamma C is 24 kilonewton per meter cube. Gamma C 24 kilonewton per meter cube. The uplift force per unit length of dam, per 1 meter length of dam, total uplift force per 1 unit length of dam at PQ. At PQ. PQ means base, na? At base, very important. At base. Clear? Total uplift force per unit length of dam. Unit length of dam will take at base, will consider. First we draw the diagram related to it. Whatever required, only those points will take and we'll draw the diagram related to it. Okay? First we are going to draw the diagram. So this is the point at which base of the dam. This is the point at which you need to derive your Dam's uplift pressure. Okay. 65 meters water head. 65 meters will consider here. 65 meters will take. This is to be taken. Take it as capital H. Take it as capital H. 65 meter. Tail water depth. Tail water depth is given 5 meter. Tail water depth 5 meter. So here consider small h. Small h. Tail water depth, take it a small h 5 meter. 5 meter. Drain hole means drainage area provided. P2 drainage area 10 meter and after that 40 meter. So wherever drainage area provided, this is 10 meter, 10 meter and this total remaining 40 meter. So this is good. Whatever given we have drawn. For this you need to derive uplift pressure diagram. Uplift pressure diagram is needed for this now. So I am taking uplift pressure diagram for the given. Uplift pressure diagram I am going to draw. Because drainage is there. Drainage hole is there. And now uplift pressure diagram will be like this. Up to 10 meters. Up to 10 meters it will be like this. After that it will go like this. After that it will go like this. You understand? So you have studied it in concrete gravity dam. For drainage area provided case, we are going to plot this uplift pressure diagram like this. What is this? This 10 meters na? Because drainage up to drain hole, so remaining is 40 meter. Remaining is 40 meter. Now this uplift pressure distribution diagram I am dividing into 4 sections. This is section 1. Section 1 which is a rectangular. Section 2 which is a triangular. And another section here I am giving section 3. This is a section 3, again rectangle, section 4 which is a triangle. You got the point. Total uplift pressure diagram I am providing as 4 sections. This 2 triangular, area 1, area 3 rectangles, area 2, area 4 triangles. Okay. What is the height of the section now? We'll take this height. So uplift pressure height, total height. Tell me total height. Gamma W into H. What is gamma W? Gamma W is 10 kilonewton per meter cube. Given height is 65 meter. Gamma W into capital H, height is 65 meter. So 65 into 10 I will take 650. Got it? You understand it? Why I am taking 650? Do you understand it? Height is 65 meter. Height is 65 meter. Gamma W is 10. So I am taking here the height as 650 kilonewton per meter square. 650 kilonewton per meter square total height. Now I am taking this height. What is small h here? Gamma W into small h. 10 into 5, 10 into 5. 50 kilonewton per meter square. Tail water depth is 5. Tail water depth is 5. So gamma W into small h, 10 into 5, 50 kilonewton per meter square. So you will get area 3 using that rectangle formula. To get area 1, area 2, area 4, it is difficult. Na? It is very much difficult. Na? You want to understand area 1, area 2, area 3. So for that I need what you need. Tell me what you need. This height is important. This height is important. So I am taking this total height here. How can we calculate the total height? Tell me anyone. This total height will have a formula. Do you remember? Do you remember? Uplift pressure head formula at drain hole. Uplift pressure head formula up to drain head. Drain hole. Gamma W into small h plus capital H minus small h by 3. Gamma W into small h plus capital H minus small h by 3. 10 into small h 5 plus capital H 65 minus small h 5 by 3. 10 into 5 plus 60 by 3. 60 by 3 20, 20 plus 5 25. 10, 250. 250. 250 kilonewton per meter square. 250 kilonewton per meter square. So what is this height we can take? This height we can consider 250. Okay? 250. Clear na? 1. You can get area 1 now. Area 1 now. Write down. A1 is equal to base into height. Height is 250. Base is 10 meter. So area 1 is equal to base into height 250 into 10. Base is 10. Height is 250. 2500. What is the unit? Kilonewton per meter. Because 250 kilonewton per meter square multiplied with 10 meter. So it will become kilonewton per meter. That is A1. A1. Now I am going to A2. What is A2? A2 is a triangular section. What is the remaining height of the triangle here? Remaining height of the triangle out of 650, 250 taken by 1. Out of 650, 250 taken by 1, 400 remaining. So area 2 half BH. Triangle section I will take half BH. Half into B is 10 meter, H is 400. Half into 10 into half into 10 into 400. So 2000 kilonewton per meter. Triangular area half BH, second one we have taken. A3. Again rectangle, A3 is again rectangle. Height is 50. Base is 40. Height is 50, base is 40, BH. Height 50, base 40. Again we'll take 2000 only, same 50 into 40. 50 into 40 will get 2000 kilonewton per meter. Done. This A4 now. A4 is needed. A4 is needed. This triangle, what is the height? Total height is 250. 50 is given up to this. Up to this 50 means this much. 250 minus 50, 200. 200 is height, 40 is base. So 200 is height, 40 is base. What can I take now? 200 into 40. Tell me. It is a triangle. It is a triangle. It is not rectangle. It is a triangle. Fourth one is a triangle. This is a triangle. So half BH we can take. Half BH will consider into half. Into half. Half into 40 into 200. 4000 kilonewton per meter square. 4000 kilonewton per meter square. So now what you can derive? A1 2500, A2 2000, A3 2000, A4 4000. What is the values? These values are representing individual uplift pressures. These values are giving you individual uplift pressures. Total uplift pressure is. Total uplift pressure is. What is total uplift pressure? Tell me. When you take total uplift pressure, sum A1 plus A2 plus A3 plus A4. Sum only. Total uplift pressure will take. Total uplift pressure will take A1 plus A2 plus A3 plus A4. Simple. 2500 plus 2000 plus 2000 plus 4000. So what is your final answer now? What is your final answer now? Tell me. 2500 plus 2000 plus 2000 plus 4000. 10,500. 10,500 kilonewton per meter. 10,500 kilonewton per meter. Completed now? Any difficulty in it? The only thing you have to understand, uplift pressure diagram. If you know this uplift pressure distribution diagram, determination of heights, question is easily completed. Answer is 10,500 kilonewton per meter. Group 1 contains 3 broad classes of irrigation supply canal outlets. Canal outlet. Group 2 presents hydraulic performance attributes. Okay. Match the following. We need to match it. Non-modular outlet, semi-modular outlet, modular outlet. 3 given. The correct match for these items in group 1 with items in group 2. Non-modular outlet. What is non-modular outlet? You tell me. What is differentiating factor? Differentiating factor for the outlets, canal outlets. Whether it is depending upon inlet or it is depending upon outlet. Whether it is depending upon supply canal, receiving water course. You understand? Example, there is a supply canal. Consider this is a supply canal. Head. So supply canal will consider it as inlet. Supply canal is head or source will take. Receiving canal is located here. Receiving canal is located. Receiving water course is located there. Now, in between supply canal to receiving water course, you are providing an outlet. This is an outlet you provided. This is a receiving water course. Receiving water course. So, depending upon type, on what it is depending. Discharge is depending whether it is depending on supply canal or it is depending upon receiving water course. We have differentiated. You understand? Discharge of the outlet, either it is depending upon supply canal or it is depending upon receiving water course. On that point, we have classified into 3 types. Non-modular. Non-modular. Discharge of outlet is depending upon both supply canal, receiving water course, both. Non-modular is depending upon both. It is depending upon both supply canal as well as receiving water course. Receiving water course, RWC. I am writing supply canal as SC, receiving water course as RWC. For non-modular outlet, it is depending upon supply canal as well as receiving water course. We will check the options. Outlet discharge, first group 1, group 2, first one. Outlet discharge depends on the water course, water levels in both the supply canal as well as receiving water course. Both given both. So, non-modular outlet P is equal to 1. Non-modular outlet P is equal to 1. So, we'll check how many options are there. So we have two options, A and D. If we have one option, our question is completed. But it is carrying two options, A and D. And semi-modular outlet. Semi-modular outlet depends only on supply canal. It is not depending upon receiving canal. Semi-modular, only head. It is depending upon head, supply canal. Outlet discharge is fixed and independent of water levels in both the supply canal as well as receiving water course. No. Semi-modular. Outlet discharge depending upon only water level on supply canal. Correct? Water level on supply canal. So it is Q. It is Q. It is P. One is P. One is P. Q is 3. Q is 3. Then modular. Modular is fixed, rigid. Rigid only. Not depending, independent. So non-modular is depending on both. Semi-modular is depending on only supply canal. Modular is not depending on anything, independent. What is remaining? Remaining is 2 only. We can write now remaining is 2 only. So outlet discharge is fixed, independent, clearly given, independent of water levels of both supply canal as receiving water course. 3 points I will tell you. Just I will brief you. An outlet is going to take, canal outlet is going to take water between supply canal to water course, receiving water course. Clear? How much outlet discharge it is going to deliver at receiving water course? If it is depending upon both the supply canal and receiving water course, both water levels, that is called a non-modular outlet. It is depending upon source. Source means supply canal only. Not depending upon receiving course. That is semi-modular. It is not at all depending. Outlet discharge, once you given the diameter, it is not changing. For example, it is a rigid modular fixed pipe. So can you change the discharge in the fixed pipe? Not possible. Fixed pipe you have given, rigid modular. It is not possible to change the discharge. Whatever the source give, whatever the receiver require, not depending upon the source, not depending upon the requirement. Not depending on supply, not depending upon demand. Depending on pipe diameter, it is fixed, independent. So what is our answer now? P1, Q3, R2, D. Completely conceptual question. Conceptual, completely conceptual question. Conceptual question. Okay? Okay? Clear? So these are the 5 questions given between 2016 to 2018, 3 gate papers. I think, hope you enjoyed the PYQ sessions. Irrigation 5 years PYQs I have finished. And you want to write online test series. Don't go to buy any online test series. Don't waste your money. Myself, Krishna Prakash, I am giving you free online test series in Unacademy app in the name of Super 30 Civil. Super 30 Civil every Thursday. When? Every Thursday your Super 30 test series every Thursday at 5 PM you are going to have in Unacademy. Check my profile, KP Civil, check my profile. You will have free online test series. Till now 6 test series completed. So every week one exam, 30 questions of one subject, subject wise test series. High level gate models of questions. You can enjoy the beauty of questions. Go through it, write online test series, don't waste your money. I am providing free online test series for you. You enjoy the test series. Then, if you are working hard for GATE and ESA, myself and my team of experienced faculty make it easy and simple for you. We teach in-depth subject and will make complicated topics into very simple and one-step solution for any exam. You may prepare for GATE, you may prepare for IS, you may prepare for state government exams, AE, AW, respective states. SSC JE, RRB JE, whatever it may be. Single step solution for all your competitive exam needs is nothing but Unacademy. Will cover in-depth concept. For example, I will take environmental engineering, 140 hours, hydrology, 60 hours, irrigation, 60 hours, open channel flow, 30 hours. This much depth no one will cover. One single coaching for all your competitive exams. So enroll now itself using the code KP Civil. Take plus subscription, enroll now itself using KP Civil code. So join the plus course. That much depth no one will give you. We are going to start new batch of GATE, ESC, AEE preparation strategy. Combined, all combinedly. GATE, ESC, AEE preparation strategy, all combined. New batch from December 1st onwards. December 1st onwards. So take, join plus subscription using my code KP Civil. Don't forget the code KP Civil. Still, you have not downloaded Unacademy app. Why to wait? Download now itself. Install the app. Click on KP Civil. Watch all my free classes. If you are willing to join plus subscription, new batch is going to start from December 1st onwards. Join plus subscription as early as possible. Okay? Let's crack it.